In the summer of 2025, astronomers witnessed something extraordinary, a cosmic visitor, unlike most objects we see in our skies. Its name is 3I Atlas, and it holds a very rare title, only the third confirmed interstellar object ever detected passing through our solar system. Before it, the world had marveled at the bizarre, cigar-shaped Oumuamua in 2017 and the more comet-like Chuy-Borisov in 2019. But now, with 3I Atlas, the story of interstellar travelers has entered a brand new chapter. The excitement around its arrival spread quickly, not just among scientists but also across news headlines, online forums, and even conspiracy channels. Wild theories popped up. Some claimed it was a disguised alien probe. Others imagined fleets of hidden companions traveling with it. But beyond all that noise, the real story is far more fascinating. This is not science fiction, it is science fact, unfolding right in front of us. The official discovery happened in July 2025, when the asteroid terrestrial impact Last Alert System, Atlas survey in Chile, flagged a fast-moving object. What made it instantly special was its unusual trajectory, a hyperbolic orbit, which means it isn't gravitationally bound to the sun. In simple words, this object didn't originate here. It came from the vast, uncharted spaces between stars, and is only making a one-time pass-through our system before vanishing forever into the cosmic dark. But the real twist came afterward. Astronomers, searching through older data, found images of this very comet hidden in archival records of the Transiting Survey Space Telescope. This discovery extended the timeline of observation, giving scientists more than just a quick glimpse. With extra months of data, they were able to calculate its path with high precision. The verdict was clear and undeniable. 3I Atlas is a true interstellar visitor. Once confirmed, telescopes worldwide pivoted to catch every possible detail. The James Webb Space Telescope, JWST, turned its advanced infrared instruments toward the newcomer in August. Its findings were astonishing. The comet's gas cloud, or coma, showed a strange chemical makeup, with a surprisingly high ratio of carbon dioxide compared to water vapor. No comet from within our solar system has ever displayed such an extreme balance. That was the first strong signal that this body was fundamentally different, born in an environment alien to our sun's neighborhood. At the same time, the Hubble Space Telescope captured breathtaking high-resolution images, revealing the comet's solid core to be about 5 to 6 kilometers wide. This wasn't a fragile, crumbling ball of ice. It was a sturdy, stable traveler holding together across its journey. And perhaps most importantly, all data confirmed there were no mysterious forces at play. The comet wasn't accelerating on its own, nor was it showing signs of artificial propulsion, unlike the debates that swirled around Oumuamua. Instead, 3I Atlas was behaving exactly as physics predicts, moving under the steady pull of gravity, shaped only by natural cosmic processes. Yet, despite its normal behavior, the alien chemistry within its icy body hinted at an incredible truth. This was a messenger from another star system, carrying frozen secrets from its birthplace across light years of space. Once, the world's most advanced observatories locked their sights on 3I Atlas. The flood of data began to reshape how scientists thought about interstellar visitors. The first surprise was its stability. Unlike some fragile comets that break apart when exposed to solar radiation, this object held firm. Observations from Hubble revealed no sudden outbursts, no violent fragmentation, and no irregular acceleration. For researchers, this was a crucial clue. 3I Atlas wasn't acting strangely. It was steady, predictable, and bound by the same physical laws that govern every other natural body in space. This meant one thing. While its chemistry hinted at an exotic origin, its physical behavior marked it as an ordinary comet, not an artificial craft or a runaway fragment of alien technology. Still, the unusual chemistry refused to be ignored. That high concentration of carbon dioxide suggested that the comet formed in a place vastly different from the zones where our solar system's comets are born. Imagine a frigid nursery at the outer edge of another star's planetary system, a place colder than the Kuiper Belt, where ice-rich particles slowly merged into frozen wanderers billions of years ago. Atlas, by carrying that strange CO2-to-water signature, is like a fingerprint of its birthplace, evidence of the conditions that existed in a completely foreign corner of the galaxy. For planetary scientists, this is priceless. It's like stumbling across a time capsule, untouched for eons, that preserves the chemical recipe of another stellar nursery. Of course, the internet had other ideas. The moment word spread about a mysterious object from another star, conspiracy theories went into overdrive. Some argued that the carbon dioxide wasn't natural at all, but the exhaust of alien machinery. Others spread rumors about a fleet of 10 or more objects traveling alongside, Atlas hidden in its shadow. A few even revived the idea of a Dyson structure fragment, a piece of some enormous alien megastructure that accidentally drifted into our solar system. These claims went viral, but when tested against actual observations, every single one fell apart. Sensitive instruments across Earth and space found no evidence of companions. Radio telescopes detected no signals. Every major facility, from Pan-STARRS in Hawaii to the European Southern Observatories, VLT in Chile, saw the same picture. One single comet, trailing a faint dust tail, moving alone through space. Even respected voices who had previously pushed for unconventional explanations admitted the evidence was clear. Avi Loeb, the Harvard astrophysicist who made headlines by suggesting Oumuamua might be artificial, stated openly that 3I Atlas showed no signs of non-natural origin. This statement carried weight, because it showed that even scientists open to bold possibilities recognized that, in this case, the simplest answer was correct. What we're seeing is not a spacecraft, not a probe, and not a fleet. It's a frozen relic of another system, behaving exactly as a comet should. In many ways, that's what makes 3I Atlas so fascinating. It doesn't need conspiracy theories to be remarkable. Its very existence challenges our understanding of cosmic formation and migration. Every interstellar visitor is rare, but each one gives us a different puzzle piece. Oumuamua confused us with its strange acceleration and elongated shape. Borisov behaved like a familiar comet, but from another star. And now Atlas bridges those extremes, chemically alien, physically stable. It is a living contradiction, ordinary in motion, extraordinary in origin. With so much fascination surrounding 3I Atlas, the natural question that emerged was simple. Is it dangerous? Whenever an interstellar object enters our solar system, public curiosity immediately turns toward the possibility of impact. Thankfully, in this case, astronomers have been very clear. The trajectory of 3I Atlas is extremely well understood, thanks to months of careful tracking from multiple observatories. Its path shows no intersection with Earth now or in the future. The closest approach won't even involve our planet. Instead, the comet will pass near Mars on October 3, 2025, at a safe distance of about 0.19 astronomical units, roughly 28 million kilometers away. To put that in perspective, that's over 70 times, farther than the distance between Earth and the Moon. In other words, this visitor poses zero threat to us or to any other inner planets. This clarity of trajectory also silences another common internet rumor, that Atlas is somehow hiding a collision course. Unlike fictional asteroids in movies, real objects leave predictable trails that can be calculated decades or even centuries in advance. Observatories like NASA's Center for Near-Earth Object Studies, CNEOS, have analyzed the comet's orbit in detail, and every model agrees. 3I Atlas will never come close enough to Earth to be a concern. After its Mars flyby, it will swing around the sun, briefly disappear in the solar glare, and then begin its slow fade into the deep interstellar night. It's a one-time visitor, never to return. But if it isn't a threat, then why does it matter so much? The answer lies in the knowledge it carries. Every interstellar object offers scientists a direct sample of material from another star system. Without sending spacecraft across light years, we suddenly get a fragment delivered to our doorstep. With Atlas, we're learning about environments far colder, darker, and richer in carbon dioxide than anything in our solar system. This helps refine the nebular hypothesis,